Okay, hello students, welcome you all to my YouTube channel Edu. So today in this video I will discuss the remaining portion of the second chapter of class 10, that is acid, bases and salts. In the first video I have discussed about acids, that means what are acids, their characteristics, what are strong acid, weak acids, and then bases, strong base, weak base with examples, and then indicators. Okay, now in this video I will discuss the remaining portion. So this video is going to be a very important, so watch this video without any skip. Okay, let's start with the pH. What is pH? It's an indicator, acid base indicator. We know what are indicators. Indicators are the substances which indicates the nature of a solution. Okay, this pH is also called universal indicator. Called universal indicator. Okay, the full form of pH, P stands for potence. It's a German word, it means power. Okay, and H is for hydrogen. H is for hydrogen. That means the full form stands as power of hydrogen, or you can say potential of hydrogen. Okay, this pH is more special. That means it's far more special in compared to all other indicators that we have discussed in my first video of this chapter. That means methyl orange, phenolphthalein, litmus, all these things. Compared to all these indicators, this pH is far more special. Now why it is special? Because all those indicators, that means phenolphthalein, methyl orange, litmus, all these indicators simply help you to determine the nature of the solution. Okay, simply nature. That means whether the solution is acidic or basic. These things you can determine with the help of those pH. That means litmus, phenolphthalein, methyl orange, etc. But specialty in this indicator is, this indicator will give you the information about the nature of the solution, as well as this, with the help of this indicator you can determine the strength of the solution. That means the acidity or the basicity of a solution you can determine with the help of this pH. Okay, now how it works. This pH actually helps to measure the hydronium ion concentration of the solution. Okay, hydronium ion, that means H positive ion present in the solution is measured, and with the help of this we can determine the strength of a solution or the nature of a solution. Okay, now let's see how it works. pH scale. pH scale has 15 different segments from 0 to 14. Okay, different segments from 0 to 14. Okay, 7 is the neutral point. Okay, 7 is the neutral point. That means the solution whose pH you will find 7, that means the solution is neutral in nature. Neutral. And if you go down from this 7 in this way, the H positive ion concentration increases. Concentration of H positive ion increases. That means acidity increases. Means acidic strength increases by this way. Okay, if you go towards this, that means up to this scale from 7 towards 14, the OH concentration of OH negative ion increases, which means the basicity of a solution. Basicity increases by this way. Okay. Now, how can you measure the pH of a solution? For this, suppose you have a solution and you have to find the nature as well as the strength of this solution. Okay. For this, you will have some pH paper. Actually, this is the main tool in this process. This pH paper is the main thing. With the help of this, we can determine the nature as well as the strength of the solution. Okay, let's. Another thing that I forgot to say, that all these segments has some characteristics colors, and these colors will be like this: deep gior. In these sides you will find violet, and then indigo, blue, green, yellow, orange, red. Okay. To find out the nature as well as the strength of this solution, we can simply dip this pH paper to this solution. Okay. When you will dip this pH paper to the solution, a characteristics color will appear in this paper. Okay. Now you have to compare the color that appeared in your pH paper with the color of the different segments of your pH scale. This is pH scale. Okay. And this is pH paper. Okay. You will have to compare the color that appeared after dipping this pH paper to the solution. The color that appeared, you will compare this color with the color of the different segments. Okay. Now, with which the color of your pH paper will match. Okay. Suppose the color of your pH paper matched with this. Okay. That means the pH of this solution is 4. Okay. If the color that appeared matched with this, that means color of these segments, that means the pH of the solution is 4. Color of the fourth segment matched with, that means the pH is 4. Likewise, if you have another solution and if you dip another pH paper to this solution, and the color that appeared after comparing this color, if you find that the color matched with this segments, color of this segment, okay, that means 12th segment of this pH scale. That means the pH of the solution is 12. Okay. From this we can simply say that, we can easily say that we know that from 7 to this side the solution are acidic, and from 7 to this side the solution are basic. Okay. Basic in nature. That means this solution is acidic and this solution is basic. Okay. Now, if you have solutions like A, B, C, D, E, that means 5 solutions, and pH of these solutions will be like this: 3, 5, 9, 7, 11, and you are asked to identify the strongest acid from these solutions and the weakest or the weak base from these solutions. Okay. Now here the strongest acid, that means strong acid, will be this one, because acidity increases by this way. That means the solution whose pH is 3, that means A is the strong acid. A will be the strong acid. That means here the strong acid is A, whose pH is 3. In compared to this solution, weak acid will be, which one will be the 5. That means B. Whose pH is 5. This will be the weak acid. Okay. And seven, whose pH is 7. 7 means neutral. That means D is the neutral solution having pH 7. And strong base. Which will be the strong base? Here the strong base will be E. That means 11. Whose pH is 11. Because basicity increases in this way. Okay. The pH increases. That means basicity increases. And weak base will be 9 will be your weak base. Okay. Now from this, what happens? See, the acidity increases with decrease in pH. Acidity increases with decrease in pH, and basicity increases with increase in pH. Okay. So by this way, you can determine the pH of your solution or the nature of your solution. Okay. Now, what are the importance of this pH? Okay, you can take the screenshot. Now let's see, is there any importance of pH? Okay, is there any importance of this pH? Importance. Okay, number one, our body, that means the animal's body, that means plants and animals' body, can survive within a small range of pH. Our body can survive within the pH range of 7.0 to 7.8. Within this range, our body can survive. Okay. And if the pH of our rainwater decreases below 5.6, pH of the rainwater, if decrease below 5.6, it's called acid rain. Okay. That can harm aquatic life. Okay. Now again, the tooth decay. Tooth decay occurs. Tooth decay starts when the pH of our mouth decreases below 5.5. Okay. 5.5. Okay. The enamel of our tooth is made up of calcium phosphate, which is considered as known as the strongest part of our body. But this calcium phosphate dissolves when the pH of our mouth decreases below 5.5. Okay, so these are some important pH that you will have to memorize. Okay. Okay, all these things are all about our pH. Now, let us start salts. What are salts? Salts. When acid and base reacts together, it forms salts and water. Okay. So for example, when hydrochloric acid, HCl, okay, hydrochloric acid reacts with base, suppose sodium hydroxide, it produces a salt called sodium chloride, NaCl, and water. So this is our salt. Now, when acid and base reacts together and forms salt, now what will be the nature of this salt? Will it be acidic or basic? What will be its nature? These things actually depends on the strength of the reacting, that means the reactant acids and bases. Okay, depends on reactant's nature. Now let's see the nature of the solution, nature of salts. When strong acid, when the reacting acids and base, when strong acid reacts with weak base, then the resultant salt will be your acidic salt. That means the nature of the salt depends on the strength of the reacting acids or base. Now let's see with some examples. When strong acid reacts with weak base, okay, it produces salts which will be acidic in nature, because here the acid is the strongest one. Okay, strong acid reacting with weak base, that means the producing salt will be acidic in nature. Okay, acidic salt plus water. Water is common. Okay, for example, strong acid, suppose if I take hydrochloric acid as strong acid, and as a weak base we can take magnesium hydroxide, MgOH twice. Okay, now the resultant salt will be magnesium chloride. This will be acidic in nature. Okay, water is common, acidic. Again, if we react between weak acid and strong base, it will produce strong basic salt and water. That means the nature of the salt will be basic in nature. For example, weak acid, suppose carbonic acid. You can take another acid. You can take different other weak acids. We have strong, as a strong base we can choose sodium hydroxide. When these two reacts together, it will form Na2CO3. That means sodium carbonate, and water is common. Okay, the nature of this will be basic in nature. Okay, now again, if both the acids and base has equal strength, that means if strong acid reacts with strong base, what will be the nature of the salt? It will be neutral in nature. Neutral salt. Okay, water is common. For example, strong acid, hydrochloric acid, strong base, sodium hydroxide reacts together, it forms sodium chloride, common salt, and water. This is neutral in nature. Again, if you make reaction between weak acid and weak base, it will form again neutral salt plus water. Okay, for example, hydrogen carbonate, weak base, magnesium hydroxide, MgCO3 plus H2O. This is again neutral in nature. Okay, that means when carbonic acid reacts with magnesium hydroxide, it produces a neutral salt called magnesium carbonate. Okay, now this is all about the nature of your salt. Now again, the important topics of our chapter is the preparation of different chemical substances from common salt, that is from rock salt or sodium chloride. Now I will discuss how can we prepare different chemical substances from sodium chloride. Okay. Now from sodium chloride we can prepare sodium hydroxide, bleaching powder, that is CaOCl2, calcium oxychloride, sodium bicarbonate, NaHCO3, this is called baking soda, and this is your washing soda, sodium carbonate decahydrate washing soda. All these chemicals can be prepared from sodium chloride. Okay. Now let's see the preparation. How can we prepare all these chemicals from sodium chloride? Now let's start with the first one. That means preparation of sodium hydroxide. How can we prepare sodium hydroxide from NaCl, that is common salt or sodium chloride? Okay. To prepare sodium hydroxide, we will simply pass electricity through the aqueous solution of sodium chloride. Okay. That means we will take a beaker and will mix water and sodium chloride. Okay. And will dissolve sodium chloride in water. That means the aqueous solution of sodium chloride, which is also known as brine solution. Okay. Now on passing electricity through this solution, sodium hydroxide will prepare. Now let's see how it happens. Okay. Suppose this is the anode. Okay. This is the anode, positive charge, and this is your cathode, negative charge. Okay. Now when sodium chloride will dissolve in this solution, it will produce Na positive and Cl negative. Okay. And on passing electricity through this solution, this chlorine will go to the anode. Okay. Chlorine will go to the anode and will lose its extra electron to this anode. Okay. And it will be like this Cl, and will wait for another chlorine. Okay. When another chlorine come, it will bond with this chlorine and will form Cl2. So Cl2 gas will evaporate. Cl2 gas will evolve through anode. Okay, and the sodium ion will go to the cathode. Okay, and from here it will take one electron. Okay, and will form metallic sodium. That means Na positive will take one electron from cathode and will form metallic sodium. Okay, and this metallic sodium again will react with the water. Okay, the water present in it will react with this sodium and will form sodium hydroxide. Okay, so sodium hydroxide will be formed in this side of the cathode. Okay, so by this way we can prepare sodium hydroxide. Okay, so here sodium hydroxide form, also hydrogen will form. This hydrogen will evolves through this. Okay, so that is how we can prepare sodium hydroxide from sodium chloride. Okay, so you can say that to prepare sodium hydroxide, we will pass electricity through the aqueous solution of sodium chloride called bromine, and on passing electricity sodium hydroxide will form in the solution near cathode, and chlorine gas will release through anode. Okay, by this way we can prepare sodium hydroxide. Okay, now the importance of sodium hydroxide, that means uses of sodium hydroxide. Sodium hydroxide can be used in different chemical manufacturing industries. Okay, you can take the screenshot. I will write the uses from here. Okay, in the manufacturing industries of different chemicals. Okay, sodium hydroxide is used as cleaning agent. Okay, it also used in textile industries. Okay, so these are some of the uses of sodium hydroxide. You can take the screenshot. Okay, now let's see how can we prepare the second one, that is bleaching powder. Bleaching powder. Bleaching powder formula is CaOCl2. This bleaching powder is the commercial name, and the chemical name of this is calcium oxychloride. Calcium oxychloride. And this calcium oxychloride can be prepared easily on passing chlorine gas over slate lime. This is the slate lime. On passing chlorine gas through this will convert it into CaOCl2, that means bleaching powder. Okay, so by this way we can prepare bleaching powder. Now uses. Bleaching powder is used in water treatment plant, as cleaning agent, used in fabric industries, There are so many other uses. Used as oxidizing agent. This is also used as germicides. Okay, you can write it here. So these are some of the important uses of bleaching powder. You can take the screenshot. Okay. Now the preparation of baking soda, that means sodium hydrogen carbonate. Chemical name is sodium bicarbonate. Sodium bicarbonate. Okay, and baking soda is its commercial name. Now how can we prepare this? To prepare this, we will mix sodium chloride, water, carbon dioxide and ammonia. Okay, on mixing this, it will produce ammonium chloride and baking soda. This is your baking soda. Okay, so by this way we can prepare baking soda. Now uses. Used as antacid. Used as antacids. Used in fire extinguisher. Used in fire extinguisher. Used in the preparation of baking powder. Baking powder. Okay, so these are some of the important uses of sodium bicarbonate or baking soda. Okay, now the last one is sodium carbonate decahydrate. Sodium carbonate decahydrate. This is the chemical name and the commercial name is washing soda. Okay, this can be simply prepared by recrystallization of sodium carbonate. Okay, that means if you add water to sodium carbonate, it will form the crystals of washing soda. Okay, so this is a very easy technique to prepare sodium carbonate decahydrate or washing soda. Now uses. Used to remove permanent hardness of water. Okay, used to remove permanent hardness of water. Also used in paper, glass industries. Okay, paper industries. Used to manufacture borax. Used in borax industries. Okay, so these are some of the important uses of washing soda. Okay, Okay, another important salts that I forget to mention, this is POP, plaster of Paris. Okay, now how can we prepare plaster of Paris? So plaster of Paris can be prepared POP, plaster of Paris. This is the commercial name. Calcium sulfate hemihydrate. Calcium sulfate hemihydrate. Okay, this is the chemical name. Now this can be prepared simply by heating gypsum. The chemical formula of gypsum is CaSO4 2H2O. If you heat this gypsum, it will convert it into plaster of Paris. Okay, so by this way we can prepare plaster of Paris. Okay, so this is all about the second portion of our second chapter, that is acid, bases and salts. If anything left, you can comment me in the comment box and I will try my level best to help you to understand each and everything from this chapter. Okay, thank you for watching this video.